Welcome back. Last video we discussed data variables and attributes and introduced a few new concepts like classes and access levels. In this video, we'll turn the story blocks we talked about in the first video into things we can make and manipulate inside our Unity editor. We'll learn about classes and a few new concepts in this video. We left off the last video by hooking up our buttons inside our code. We can test if this works by grabbing the variables and changing their text properties inside our start. So let's give it a try and see what happens. I'm just putting in filler text so we can identify which button is which. As you can see, unlike our story text, we're not setting these values to a different variable. We're setting these values directly with the data we want them to store. This is okay for now because we're just using this to test if everything is working, but usually you don't want to assign variables directly to a data value in the body of your code. If you do that, your code can become difficult to read and change if it gets really complex. Now that we're done writing our code, let's run it inside Unity, and we should see that our button's text changes, and in fact, they do change. But you may be wondering, what do we do now? Everything is hooked up, but the buttons aren't reacting to anything, and we don't even have a way to progress through the story. First, let's create a way to actually bring our story into the game. We're going to create a new file to help store all of our story text and options. Let's delete most of the code we just wrote and put it into its own class. Last video, I briefly mentioned classes and said we had already created a class. And if you look at line 6 on our game logic file, you'll see public class game logic : mono behavior. So we have actually been using a class this entire time. All a class is a way to separate code into its own group. We want to separate our code into different classes to make it easier to understand how our code is functioning and interacting with each other. In this series, the logic of our game is really simple, so it's okay to put our entire game logic inside of one class. But you can imagine a first-person shooter. You'll have one class that handles shooting a gun, and then the different class that handles the health system, and another one that handles enemy AI, and so on. So in our case, our game logic script will navigate through our story, but we don't want to store our story inside this class because those are two different tasks that we want to accomplish. Let's look at line 6 and dissect how this line is being written, or its syntax. As you can see in the beginning, we have our access level. In this case, it's public. We'll discuss access levels in the next video. After our access level, we have our data type. In the last video, I described a class as a data type, but I didn't mention it when I described the different types of data we can hold in a variable. The reason why is because classes don't have a defined value they have to hold. Classes are just like groups. Like in real life, different groups vary wildly. The next thing after the data type will be our class's name. In our case, it's game logic. If you remember in the previous video, I made a point to say that when you name your script in the Unity editor, you have to name it directly after creating it. Unity requires that our class name and C# script file name are identical. Unity will automatically do this for you, but if you click away before naming it, it'll just name it the default name. This is okay, you can change the name after the fact, but you just have to make sure that you also change the file name. So not as big of a deal as it might have made it out to be, but just for convenience, it's better to name while creating the file so Unity can name the class for you. Okay, after we have a : and mono behavior, this is called inheritance. Inheritance isn't something we'll cover in this series because it's a little more advanced of a topic, but to briefly overview inheritance, inheritance is just what it sounds like. You are inheriting code from a different source. In this case, we are inheriting code from the class mono behavior. Mono behavior is a class that Unity has already written for us and is held within the Unity namespace. Mono behavior handles a bunch of functionality that you would want for most of the classes you create. This includes being able to put our code on a game object, and our void start and void update actually comes from mono behavior. So it's really useful, and you would want it in most of the classes you create, so Unity automatically inherits this for us to save us time. The : just signifies that you want to inherit from a source, and everything after the : is where you're inheriting from. After the inheritance, you'll notice that there is no semicolon. There is an open curly brace on line 7 and a closed curly brace on line 25. That's just how you write a class. Everything inside the open and closed curly brace represents what's in the class. So you might see that our void start and void update also share this pattern, but these are not classes. They're called methods, and we'll talk about that in the next video. But for now, just know that classes and methods are different. That is how you write a class or the syntax of a class. Let's create a new class to store our data. Usually you only hold one class inside one file, so let's return to our Unity editor, create a new C# file, and call this storyblocks. And actually, I think storyblocks isn't the best name because each instance of our story block will be called storyblocks. I think it makes more sense if we name it singularly. So as I mentioned before, we can change the name after making it, but we just have to make sure to change the class and file names so they match. Let me just remove the S and everything should be working fine. Okay, now one of the reasons I talked about inheritance is because we actually don't want to inherit from mono behavior for our story blocks. We don't need to attach it to any game object because it's just storing information. We're not actually doing anything with information besides storing it and reading it. Unity actually has a different class we can inherit from specifically for the purpose of storing information for other classes to use. This class is called scriptable object. As soon as we replace it, you'll notice that our start and update are no longer blue. That's because we're no longer inheriting from mono behavior. So the two methods don't have any functionality, and if we attempted to put this script on a game object, it wouldn't work. Since the start and update are essentially useless now, let's remove them. I mentioned that this class will just store information, which is true, but not totally accurate. Basically, what we're doing here is we're making a template of information that we want to store. We're not actually putting any data into this class, we're just making the guideline we want all of our story blocks to follow. So what do we want to store in our story blocks? Well, we have our story text and the options we want our players to choose from, so let's make variables for those. First, our story text, and to write that, again, we put in our access level, the data type we're storing, and then the name of the variable. And let's do that for the rest of our options as well. Okay, great. So we made the template, but how do we actually make it? If you guess we'd use an attribute, you would be correct. If you remember the last video, attributes are how the Unity editor interacts with our code. In this case, we want to use an attribute on this class to allow us to create scriptable objects inside our project panel. Attributes are written with square brackets, and the attribute we're going to use is create asset menu. This attribute requires a property to be put into it. To do that, we just type in a pair of parentheses, and we're going to assign the menu name as storyblock. Attributes all vary in what they can do and what they require to function, so don't worry too much about memorizing how to write them. You'll only be using a handful of them when starting out. If we return to our project panel, right click and look at the very top, we have our new storyblock scriptable object. Let's go ahead and click it, and if you see, nothing pops up. Nothing is shown because we need to add our serialized field attribute to our variables. So let's go ahead and do that. When we save and it compiles our new code, you'll see we now have access to assigning values to each variable. But there is a slight issue depending on how you wrote your story. In my story, I only have 3 options for any given story block. So I actually don't need this 4th option. But even in my simple story, some blocks only have 2 options and some only have 1. Maybe in your story you have a block with 10 options, but we only have 4 slots. It would be incredibly helpful if we could vary how many options we could have on each story block. Unfortunately, there's no way to do that, so go ahead and look through your story tree. Just kidding. The solution we're looking for is called an array. Arrays are a way to structure data into groups. You can think of it like a box of chocolates. You have a chocolate piece in every slot, and each slot is labeled for you. So to convert our options into a single options array, let's change the name of this variable so it makes more sense from option 1 to options because it's holding all of our options now. And to convert it into an array, just write an open and close squared bracket with our data type. This tells our code that it's not just one string we're holding an array of strings. So if we refresh and look at our storyblock scriptable object, we have a new dropdown called options. And if we click on it, we can now add options and take away options. Here, each element in our array is also labeled with a number, starting from 0. That's important to remember when we're coding. We always start counting at 0. Here you can see we have 4 elements, but our labels for elements only go to 3 because our first element starts at 0. I'm just trying to emphasize that we start counting at 0 because it has implications for us later on when we're coding. Okay, cool. Now that we can change how many options we have in each of our story blocks depending on what we wrote, let's make this story block a little more manageable. I'm going to introduce a new attribute to you called text area. Text area will make it easier for us to type our story so we can expand our text field. Let's type in our squared brackets and text area, and this attribute can take two properties. If you remember, with the create asset menu attribute, we assign properties inside of the parentheses, and with text area, the first number will be the minimum number of lines you want, and the second number will be the maximum, and we separate those with a comma between. I think 3 for our minimum makes sense, and we shouldn't ever need more than 8 lines, so let's write 8. If we save and let our Unity editor compile, you'll see that the story text area is bigger, making it easier for us to write our story. Now let's put some information into our story block. It'll automatically save anything that we put in it. This is how we'll create all of our story blocks for our game. And let's rename the story block to beginning story block. And our project panel is getting a little messy, so let's do some quick organization and create some folders. One for our script, and one for the story blocks we're going to create. Now that we have this set up, let's return to our game logic script and start using these story blocks in our code. So instead of storing a string in this variable, we want to store our story block. So let's change our data type from string to the new class we created, story block. Now, if you see, the string is giving us an error because we can't assign this variable a string value anymore because it's no longer built to hold a string. It's built to hold a story block. So let's get rid of the string. And we also want to assign this inside our Unity editor, so let's add the serialized field attribute before it. Before I continue, on line 16, you can see that our beginning story text is throwing an error because this is no longer a string. Let's just see what happens if we try to save this. If we return to our Unity editor and try to stick our story block in, you'll see we don't even see our beginning story text variable. If we look at the bottom of our Unity editor, you'll see a red warning message. This is a condensed version of our console, and you can see a bunch of stuff, so let's quickly go over how to read errors. The first section tells you where the error is in your project. So if we head inside our assets folder, then our scripts folder, then finally our game logic C# file, that's where we'll find our error. The first number is going to be what line our error is at, and the second number is going to be how many characters into the line the error is at. So on line 16, 26 characters into the line, we have our error. And if we look at our code, it is line 16, and including spaces, our error is 26 characters into our line. The next section is going to be the error code. This code just represents the type of error that is present. The next section explains what the error code means. In this case, error code CS0029 means we cannot implicitly convert type story block to string. This is just saying that we can't turn one data type into another data type automatically. Because of this error, Unity did not compile this code, and that's why we don't see our beginning story text variable in our editor. So to eliminate that, let's just comment out that line of code. Commenting is just using 2 forward slashes, which tells our computer to ignore everything after the slashes. You can see it is used on lines 13 and 20. Comments are a helpful feature in coding to write notes about how the code is working for yourself in the future, and also for other developers that might be working on your code. And in this case, we're using the commenting feature to remove the code without deleting it. And now if we check, the error is gone, and our game logic now shows the beginning story text variable. Now we can plug in our story block scriptable object into this field. Great, let's return to our code and change the variable's name to something more appropriate. I'll name it beginning story block instead of text because this is no longer a piece of text, but an entire block. Let's uncomment this line and address the issue. We don't want the entire story block. What we want is just the story text. So just like our Text Mesh Pro component, we use a period and type in what we want to access in our story block. If we take a look, we want to access the story text. So let's type that in. As you can see, it's still giving us an error. I'll be going over why we're getting this error and how to fix it in the next video. We'll also be going over access levels and methods. In this video, we went over a lot. We learned about classes, inheritance, arrays, how to read errors, and commenting. The next video will be released next week, but if you want access to it earlier, you can head over to Patreon, where that video and the rest of the series are already available. Okay, I'll see you next video.